Okay, so to solve an equation for y, that means just get the y by itself, right? So what should I do? Subtract 9 from both sides. So I have x minus 9 equals 4y. Then what? Divide by 4. Divide by 4. So y is x minus 9 over 4. Am I allowed to do this? X over 4 minus 9 over 4. Is that true? Yeah. Either one of those is fine. I know. Okay, so the concept of an inverse, which is what we're going to talk about today, may be more familiar to you than you realize. Many actions from your everyday life can be undone or reversed. So for example, I want to describe the inverse or undoing of putting on your sock, followed by putting on your shoe, followed by tying your shoe, right? So that's the order that you get ready to leave the house, right? How do you undo it? What do you do first if you have to undo what you did? Untie your shoe, followed by take off your shoe, and then lastly, take off your sock. Right? And then you end with a barefoot, which is where you started originally. So what do you notice about the actions that you have to take to do something versus undo something? Yeah, you got to reverse the order. So similar to undoing everyday life processes like putting on your shoes, right? An inverse operation idea in mathematics involves one operation undoing or reversing what was done by a previous operation. So if I start with the number 2 and multiply by 3, what's my result? 6. To undo that, if I want to get back to 2, how do I would divide by 3, right? To undo multiplying by 3, you divide by 3, and that brings me back to 2. So when we perform an inverse operation in math, we get back to where we started. And I like this, this term. It means we make a round trip, right? Whatever you did, you undo it, you made a round trip. You landed right back where you started. So if I want to undo or reverse, subtract 1 from x and then multiply by 3. Okay, so I'm starting with an x, and this is my list of do, right? This is my do list. So I start with an x, and first I'm going to subtract 1 from x. So how do I write that down? X minus 1. And then I'm going to multiply the result by 3. What do you get when you multiply that by 3? Sure, I could put x minus 1 in parentheses with a 3 in front of it. You could also write 3x minus 3. Yeah. All right, so if I want to undo, right, what's the first thing I want to do in order to undo what I did? Yes, I'm going to do what I had. I have to start with 3 times x minus 1, and I have to divide by 3. Right? That'll undo the multiplication by 3 that I did last. Right? And that just leaves me with x minus 1. Then what do I do? Add 1, and I'll get the x back. Right? So I have to do x, take my x minus 1, add 1 to it, and I get the x back that I started with. Okay, so let's say f of t is a function that models the height of corn seedlings in inches t days after they've been planted. Okay, so I want to make a table of values for f for the domain 0 to 3. So I'm just picking some values from 0 to 3, and I'm going to plug them in, right? So at time 0, what's the height of my corn seedling? 6. I'm plugging 0 into my function for t. 6 inches. All right, what about at time 1 day later? 8 inches. 2 days later, 10 and 12. Yeah. All right, so I'm going to write this as a list of ordered pairs. Instead of like a table, I'm going to write this as 0, 6, 1, 8. These are T's and H's that you would plot as pairs. So I have 0, 6, 1, 8, 2, 10, and 3, 12. All right, so suppose I wanted to know how many days it would take for the height of the seedling to reach H inches. How would I find it? How many days, maybe if I give you a number, it would be easier for you to answer me. How many days would it take for the height of the seedling to reach 20 inches?
Solve for t.
Yeah, you solve for t. If you want to know how many days t, you're going to be solving for t. So I would write down h equals 6 plus 2t, and I would solve that for t. So subtract 6. So I have h minus 6 over 2 equals t. So I would just solve for the t. So in this equation that we just came up with, h is now the input, right? H is now the input and t is the output, or h comma t's if I was going to graph it. I interchanged the role of the variables. What used to be the output, the height, became the input. So let's make a new table of values, right? So this was my old table of values, time and height. We already did that. So my new table of values, if I give you the h and you tell me the t, I could use this formula, right? If h is 6, what time does that happen? 0. If h is 8, what time does that happen? 1, 2, 3. Right? So my set of ordered pairs is going to be 6, 0, 6, 0, 8, 1, 10, 2, and 12, 3. All right, so what do you notice about the two tables or the two sets of ordered pairs? They flipped. It just changed the input and output. Okay, so the inputs and outputs, right, which we usually think of as the x and the y, right? In this case, t and h, right? The inputs and the outputs switched. So these are basically the two functions I have, 6 plus 2x and x minus 6 over 2. I went back to x's and y's instead of h's and t's, right? Those are called inverse functions. Those are functions that undo each other. Okay? So the fact that g is the inverse of f is usually expressed by writing g with a different name, right? We write f with that little -1, and that just means it's related to f. It's like the opposite of f. It's the thing that undoes f. And you read that out loud as f inverse, that f to the -1. It's not an exponent. You just read f inverse. So for example, if you have f of x and g of x, 6 plus 2x and x minus 6 over 2, we just saw that those things undo each other. So we could rename g with that f to the -1 of x. Rename it f inverse of x. Okay, so here's the really big idea, inverse functions. F and g are two functions that create a round trip, right? Where if you apply the function g and then you apply the function f, they undo each other and you just get the x back. Whatever number you plug in there, if g is times 3, then f would be divided by 3 and you land back at the exact number you plugged in. Round trip. And it has to work both ways. You can either multiply by 3 and then divide by 3, or divide by 3, then multiply by 3. They undo each other either way. So we call those f and g inverses. So this definition is the same as the visual process that we started with earlier today. You start with x, apply the function g, and you get g of x, right? Then we're going to apply the function f, and that's going to bring us back to where we started at x. Yeah. And you can do it in the other order also. Here we apply g followed by f. Here we could start with x, apply the function f, the result is f of x, then apply the function g, and you come back and you get x. Yeah.
So as long as you have an inverse function, that you're always whatever answer.
Yep. Yep. Yeah, as long as you know that the two functions are inverses, you don't have to do anything. You know it's going to bring you back to where you started. Yeah. That's it.